let me introduce you to your speakers today. So we've got Natasha King and Dave Cook. Natasha is our residential product manager and Dave is our group technical product manager. So you're going to be in good hands today. So with no further ado, over to you guys.
Thanks, Lena. Welcome, everyone. We're here to present the seminar for domestic retrofit legislation and guidance.
During this presentation, we will be covering the following from the refurbishment perspective: why we need to ventilate, the building regulations, both parts F and L where applicable, ventilation systems, design and compliance, including NIC, EIC training schemes, and then finishing off with a summary and any questions.
We were founded in 1936 by a marine engineer called Joe Acaster, the owner of Axia fans, who manufactured DC fans that were used on ships and tankers. He saw a market for domestic and commercial fans and invented the world's first electrically operated extract fan, produced in Bakelite. This slide shows a picture of the Silence 6, which was manufactured at the factory in Putney, West London. And today, now called Vent-Axia, we continue to improve the indoor environment and for our customers.
Vent-Axia is a proud UK manufacturer producing products across 3 UK sites for the UK and export markets, with our goal of improving the indoor air quality for our customers. Our manufacturing facilities across the UK are located in Crawley, Dudley and Reading.
So why do we need to ventilate our homes? Modern buildings and modern methods of construction are resulting in extremely airtight dwellings with very limited natural air movement. This can result in trapped moisture, VOCs, allergens, and other harmful pollutants in the atmosphere. Within the refurbishment sector, energy efficiency measures are often applied which increase the air tightness. However, this can adversely affect the ventilation and indoor air quality within the building.
With people now spending up to 90% of their time indoors and the increase in home working, the average family can produce up to 15 litres of moisture per day, or 27 pints if you'd like to think of it that way. Moisture in the atmosphere is created by normal household activities such as cooking, washing and bathing. Even when we are asleep, we produce approximately 400 millilitres of moisture per person per hour. Other activities such as breathing and sweating produce approximately 550 millilitres of moisture per person per hour. Cooking with gas generates approximately 3 litres of moisture per day. And one of the other main culprits is drying clothes indoors at approximately 1.5 litres of moisture per person per day. Air is like a sponge. The warmer it is, the more moisture it holds. As moisture is generated in and around the home, a lack of heating and air movement means this moisture is not reduced and looks for a cold surface to condense on, potentially leading to more serious issues. Prolonged condensation leads to mould growth, which is simply a fungus produced when the relative humidity exceeds 70%. The presence of mould and other similar compounds are common triggers for the onset of asthma and other forms of respiratory disease.
To overcome condensation, 3 elements have to be in place: adequate heating, adequate insulation, and adequate ventilation. If you do not combine these 3 elements, you may reduce condensation, but you won't overcome it. This is an extract from BS 5925/1991, section 4.5. The contribution made by ventilation is to lower the moisture content of the internal air by diluting it with outside air, which normally has a lower moisture content. Within the 2021 approved document F, ventilation must be considered when making improvements to the insulation and/or airtightness of a property.
Moving on to the building regulations for England, specifically Part F for ventilation and Part L for conservation of fuel and power. We will be looking at Volume 1, which applies to dwellings such as residential homes. There is also a Volume 2, which applies to buildings other than dwellings, such as commercial properties.
Historically, building regulations across the United Kingdom were combined, but over time this has changed to having each constituent country having its very own version of the building regulations. England was the first to publish its latest building regulations, and we expect other countries to follow shortly. With each now having finished their consultation period, they are set to publish their documents within the next year. Once these are published, we will update this presentation to include them. The Welsh publication was actually released the day before yesterday, and we are in the process of reviewing them.
The new 2021 edition of Part F and L were published on the 15th of December 2021 and take effect on the 15th of June 2022 in England. This means any new applications following this date will need to meet the 2021 edition. Any applications made prior to this date will be applicable for a 12-month grace period, which ends June 2023. Following this, each individual plot must follow these regulations in order to comply. Historically, building regulations applied to each site, multiple houses. This has now been changed to being specifically applicable to each plot, i.e. the individual house. This means if a site is designed to previous regulations, hasn't started every plot by June 2023, any remaining plots would need to be redesigned to meet the 2021 edition. This timeline applies to both new build sites and work on existing buildings.
In 2010, there was the introduction of the Domestic Building Services Compliance Guide, along with an update to the building regulations. This created a more stringent process around the installation and commissioning of ventilation systems. Alongside this, there were also industry guides on good practice and good practice guides to ensure compliance.
The main focus of the 2021 edition is health and energy efficiency, which we see as a positive move following the COVID-19 pandemic. The regulations look to, firstly, minimise entry of external pollutants, ensure humidity and pollutants are extracted effectively and efficiently, and finally, setting minimum levels of fresh air to ensure good occupant health. Key elements of the Domestic Building Services Compliance Guide have now been included within the new approved documents ADF and ADL.
Approved Document F interacts with various other approved documents. Whilst we don't go into each one into detail within this presentation, it is worth noting the documents involved and some of the interactions. Part B is all about fire safety. This applies to ductwork and penetrations through walls and fire structures. Part B also offers guidance on escape windows and openings. These may well be larger than those required for ventilation in Part F and should take precedence. If in doubt, always consult with the fire officer.
Part J is regarding combustion appliances and fuel storage systems. Part F cannot supersede Part J as this may be safety critical. For example, when permanently open air vents are required by Part J for the purpose of combustion. Ventilation fans may cause combustion gases to spill from open fluid appliances. These combustion gases may fill the room instead of going up the flue or chimney, even if the combustion appliance and fan are in separate rooms. The guidance in approved document J should be followed when installing, testing ventilation appliances. Combustion appliances must operate safely whether or not the fans are running.
Part K covers protection from falling, collision and impact, and Part M covers access to and use of the building. For example, manual controls should be within reasonable reach of occupants.
We're now going to talk about the different ventilation systems the new building regulations recognise. For those of you familiar with the old regulations, the various ventilation systems within the new Part F are no longer classified between Systems 1 and Systems 4. On the left, we have natural ventilation, previously known as System 1, background ventilation and intermittent extract fans. In the middle, we have continuous mechanical extract ventilation, previously known as System 3, continuous mechanical extract or MEV. And finally, on the right, we have mechanical ventilation with heat recovery, previously known as System 4, continuous mechanical supply and extract with heat recovery, or MVHR. So there are now three types of prescribed ventilation systems with passive stack formerly known as System 2, removed. Other system types, such as positive input ventilation, or PIV, may be used to comply, but expert advice should be sought.
The minimum intermittent and high extract rates between the 2013 and 2021 editions remain unchanged and are presented within tables 1.1 and 1.3 respectively. For intermittent systems, these are 60 or 30 litres per second for a kitchen, 30 litres per second for a utility room, 15 litres per second for a bathroom, and 6 litres per second for a toilet. For continuous systems, these have minimum high rates of 13 litres per second for a kitchen, 8 litres per second for a utility room, or 6 litres per second for a toilet.
However, a key change within the approved document F is the whole dwelling ventilation rates, which have increased by almost 50%. When calculating the whole dwelling ventilation rates, the greater of the following is used. Firstly, the ventilation rates taken from table 1.3 and selected depending on the number of bedrooms within the dwelling. For every additional bedroom beyond this table, an additional 6 litres per second should be added. The minimum ventilation rate should not be less than 0.3 litres per second per square metre of internal floor area, including every floor. If the whole house rate exceeds the high extract rate or the boost rate, there is no specific requirement for boost speeds to be increased above the whole house rate, but dependent on various factors such as lifestyle, you should consider a minimum of plus 10% boost. It should be noted that for a dwelling with one habitable room, for example a bedsit or a studio, would need to meet a minimum ventilation rate of 13 litres per second.
Mechanical ventilation systems in regards to approved document L are largely unchanged, but continue to specify that systems should be designed to minimise electric fan power, which is called specific fan power, and should not be worse than shown in this table. The only change here is the heat recovery efficiency, which was originally stated to be a minimum of 70% within the Building Services Compliance Guide in line with the 2013 edition, and has increased to a minimum of 73% as part of the 2021 edition. There continues to be a requirement to have a summer bypass and variable speed controller for supply and extract ventilation systems.
When work on an existing dwelling includes work on the ventilation, for example, building an extension, adding a wet room, or replacing part of the ventilation system, the ventilation work should meet the relevant standards in this approved document. Excuse me. Furthermore, when other work is carried out that will affect the ventilation of the existing dwelling, for example, replacing windows or doors, or doing energy efficiency work, the ventilation must either meet the standards in the relevant approved document, or not be less satisfactory than before the work was carried out. It should be noted that infiltration should be considered as part of the ventilation system. Infiltration is the natural ventilation leaking through the structure of a building and any fixed openings such as trickle vents.
Many existing dwellings are ventilated through infiltration rather than purposeful ventilation. Energy efficiency measures carried out on existing dwellings might reduce infiltration and cause the dwelling to become underventilated. Building work should not reduce the ventilation provision of the dwelling unless it can be demonstrated that the ventilation provision after the work is carried out meets the minimum standards approved by document F. When carrying out energy efficiency measures to an existing dwelling, an assessment should determine what, if any, additional ventilation provisions are needed based on the estimated impact of work. The assessment should be carried out by one of the following means: applying the simplified method in paragraph 3.8 to 3.13 in ADF 1, or seeking expert advice, which may include carrying out an air permeability test that follows the procedure given in approved document L volume 1. A side note to this is that BSI PAS 2035 is considered to be an adequate means of demonstrating compliance with paragraph 3.6. The simplified method set out in paragraph 3.8 to 3.13 is designed to apply to an existing dwelling that is assumed to have an adequate means of ventilation through a combination of purpose-provided ventilation and infiltration. If the property differs significantly from this assumption, the requirement of paragraph 3.6 must still be met. This should be demonstrated through seeking expert advice or using another suitable method. When carrying out energy efficiency measures on an existing dwelling, Table 3.1 should be used to calculate the number of major and minor energy efficiency measures involved. This calculation should include all of the following: energy efficiency measures fitted since the original dwelling was constructed, to consider accumulation of measures, and energy efficiency measures that are planned. Please note, where specific energy efficiency measures are not included in Table 3.1, the most similar category should be chosen. If the result is category A, then there is likely to be no further ventilation provision is required. If the result is category B or C, then further ventilation should be provided with one of the following: natural ventilation, i.e. intermittent fans, following the guidance for natural ventilation systems. However, expert advice will be required if the result is category C. Or you can go down the continuous MEV systems route, or MVHR systems following the system specification guidance. So just looking at the table on the screen, you can have up to 2 minor category measures and still fall within category A, and no further ventilation provision is required, whereas 1 major will automatically put you into category B, where further ventilation may be required. As you can see from the table, installing cavity wall insulation to an external wall is classified as a minor measure, but sealing and or insulating a suspended floor is considered as a major measure. To assist in evaluating the ventilation provision of an existing dwelling, Table D1 of the Appendix D should be followed. You can find this on page 48 of the document available on the government website.
Replacing windows. Windows with existing trickle vents are used. New trickle vents must not be smaller than those existing, and they must be controllable, manually or automatic. Windows without existing background vents, when replacing these, the windows will likely increase the air tightness of the building, reducing beneficial ventilation. Therefore, if an MVHR system is not used, it is necessary to either incorporate background vents in the replacement windows to the following: for habitable rooms, a minimum of 8,000 millimeters squared, for kitchens, a minimum of 8,000 millimeters squared, and for bathrooms, a minimum of 4,000 millimeters squared. Or, if the dwelling will have a continuous mechanical extract ventilation, MEV system, installing background ventilators in any replacement windows which are not in the wet rooms, with a minimum equivalent area of 4,000 millimeters squared in each habitable room. Or finally, other ventilation provisions if it can be demonstrated compliant to building control.
The requirement for adequate ventilation to an additional habitable room, excluding conservatories, can be met if the additional room is connected to an existing habitable room, which now has no window openings to the outside. Paragraph 1.42 to 1.44, referenced later in this presentation, should be followed. Or the additional room is connected to an existing habitable room that still has window openings to the outside. The following conditions apply. If the existing habitable room has a total background ventilator equivalent area of less than 5,000 millimeters squared, if the existing habitable room has a total background ventilator equivalent area of at least 5,000 millimeters squared, both of the following should be provided: background ventilators of at least 12,000 millimeters squared equivalent area between the 2 rooms, and background ventilators of at least 12,000 millimeters squared equivalent area between the additional room and the outside.
An alternative to the previous method of demonstrating adequate ventilation to the additional habitable room is the use of a single room heat recovery ventilator. The supply rate required can be calculated as the whole dwelling ventilation rate times the room volume divided by the total volume of all habitable rooms. Alternatively, if there is a mechanical ventilation system already installed, this could be extended into the room. Purge requirements from paragraphs 1.26 to 1.31 must also be observed for the new room.
Conservatories with a floor area of 30 metres squared or below are exempt from the Part F requirements. Above 30 metres squared, the ventilation rates for a new conservatory could be achieved via background ventilators. This should be followed regardless of ventilation provisions in existing adjacent rooms. Purge requirements must also be observed.
When a wet room is added, the whole dwelling ventilation should be extended and extract ventilation provided via one of the following: either intermittent extract fan with a background ventilator of at least 5,000 millimeters squared, continuous extract, or single room heat recovery. Single room heat recovery must use the high speed from table 1.2 minimum intermittent extract rates for the room that has been added for its high rate, and 50% of this value as the continuous rate. In this case, background trickle vents are not required. Again, purge ventilation is still required.
Where building work is carried out in a kitchen or bathroom, any existing fans, including cooker hoods where they extract to the outside, should be retained or replaced. Appropriate checks should be made to determine whether any retained ventilation devices are correctly working. If there is no ventilation system in the original room, it is not necessary to provide one in the refurbished room. However, additional ventilation may be necessary if refurbishment work is likely to make the building less compliant with the ventilation requirements of the building regulations than it was before the work was carried out. If an extractor fan or cooker hood is replaced and it uses the existing cabling, this does not need to be notified to building control.
From here, we explain all the system types for approved document F in detail, starting with natural ventilation with background ventilators and intermittent extract fans. This is guidance suitable only for less airtight dwellings. These systems are formally known as System 1. Intermittent extract fans should be fitted in all wet rooms with correctly sized background ventilators, also known as trickle vents, installed.
Here is an animation of natural ventilation. As you can see, background ventilators allow air to infiltrate into the building, and in this example, these are integrated within the windows. Intermittent extract fans are located within wet rooms, bathrooms, and the kitchen, and are only operated either by manual override or automatic controls, such as an integral humidity sensor. These then allow the moist, stale air to be extracted to the outside.
Extract rates for intermittent systems are unchanged, but key points to be aware of: if a wet room has no external wall, the fan should be extracted at 4 air changes per hour in order to meet the purge ventilation standards. It should be noted that for larger wet rooms, this may exceed the minimum extract rate. For example, if an internal bathroom of 15 square meters would need a minimum intermittent rate of 60 meters cubed per hour, or 16.7 litres per second. Any automatic control, such as humidity control, should have a manual override to allow the occupant to turn the extract ventilation on or off. And if no window is present, the fan should be provided with controls which continue to operate for at least 15 minutes after the room is vacated.
Background ventilators are now defined by either single-storey or multi-storey use, as shown in table 1.7 on the right. There is a 20% increase in area for habitable rooms and a 60% increase in area for kitchens. Fans and background ventilators should be at least 500 millimeters apart if installed in the same room, and if an external facade faces an area of sustained and loud noise, an attenuating background ventilator is needed.
A key note to be aware of is that background ventilators are not recommended in dwellings with only one exposed facade, or if a dwelling has at least 70% of its openings on the same facade. This will mean that apartments will likely need to move towards mechanical extract ventilation or mechanical ventilation with heat recovery, not intermittent fans.
If there is a habitable room that does not have any windows, you will need to ventilate through another room. In order to comply with this, there should be a permanent opening between the two rooms of at least 1/20th of the combined floor area of the two rooms. Background ventilators of at least 10,000 millimeters squared equivalent area, and purge ventilation should be present. This will also apply to continuous mechanical extract ventilation.
A system for purge ventilation is required in each habitable room to move high concentrations of pollutants from occasional activities, for example, removing paint smells. Purge ventilation should be capable of extracting a minimum of 4 air changes per hour per room directly to the outside. Purge ventilation should be delivered through either openings such as windows or doors, or a mechanical extract system. Where purge ventilation is delivered through openings such as windows in a habitable room, the minimum opening areas which are specified in Table 1.4 should be achieved. There are minor changes when compared to the 2010 edition, where it previously distinguished between doors and windows. These have now merged into the table we see as Table 1.4. Purge ventilation applies to all ventilation system types within approved document F.
All internal doors should allow air to flow through the dwelling. The requirement is that there needs to be a free area equivalent of 10 millimeters undercut to a 760 millimeter wide door, which means either a 10 millimeter undercut above a finished door or a 20 millimeter undercut above an unfinished floor. Although often overlooked on site, this requirement is just a minor rephrasing of the requirements compared to the previous regulations. Door undercuts apply to all ventilation system types within approved document F.
We move on to the next type of ventilation system, continuous mechanical extract ventilation, which can be achieved through two different types of system or a combination of such. Firstly, decentralized mechanical extract ventilation, or DMEV, which is a standalone continuous running extract fans that is installed within the wet rooms. Or secondly, continuous mechanical extract ventilation, MEV, which is a remote fan installed in a loft or cupboard, which continuously extracts air from the wet rooms via ductwork. There is no opportunity for heat recovery with either decentralized MEV or centralized MEV.
Here is an animation of decentralized mechanical extract ventilation, DMEV. Similar to the intermittent extract fans, background ventilators allow air to infiltrate into the building. Please note these are only installed within habitable rooms and not wet rooms. With the constant running fans located in wet rooms, these fans operate constantly at a lower speed to ensure consistent removal of moist and stale air.
This is an animation of a centralized mechanical extract ventilation, MEV. Again, we have background ventilators which allow the air to infiltrate into the building. Valves and ductwork are located within the wet rooms, which allows the MEV unit to draw the moist, stale air through the ductwork and to the outside.
For MEV and DMEV systems, we have to look at a high or boost rate and also a continuous rate. The minimum high extract rate is defined in litres per second for each of the wet rooms. Kitchens at 13 litres per second, utility rooms at 8, bathrooms at 8, and sanitary rooms at 6 litres per second. The continuous extract fan has to be calculated in two ways, and the larger of the two volumes will be used. Step 1 is to obtain the rate from the number of bedrooms, and step 2 is to multiply the total floor area of the property by 0.3 litres. Should the continuous rate be higher than the minimum high rate, then the continuous rate should be used for the boost as well. There is no need to increase the speed to any of the additional boost. However, dependent on various factors such as lifestyle, you should consider a minimum of plus 10% boost.
Background ventilators should be installed in the habitable rooms, but should not be installed in wet rooms. When installed in each habitable room, they should have a minimum size of 4,000 millimeters squared. It should be noted that there needs to be a minimum number of ventilators in the property, which equals the number of bedrooms plus 2.
A point to consider is prevailing wind and exposed facades. This can be combated with any of these points. Ducting to another facade, use of constant volume flow rate units, or seeking expert advice. The best solution is to use constant volume fan units, particularly in scenarios where ducting to an alternate facade is not practical.
We move on to the final ventilation type found within approved document F, mechanical ventilation with heat recovery, or MVHR. MVHR is a whole dwelling ventilation system that supplies and extracts air continuously at a low rate, with the option to increase airflow rates for boost as and when required. The unit is typically installed in the loft space or cupboard and connected onto rigid ducting, which supplies fresh filtered air to the habitable rooms and extracts stale polluted air from the wet rooms. The unit incorporates a polymer heat exchanger that recovers energy from the stale moist air and tempers the incoming air before it is delivered to the habitable rooms.
Unlike intermittent extract and continuous mechanical extract fans, background ventilators are not required for MVHR. Stale and moist air is removed from the wet rooms via the ductwork, which is then extracted to the outside. Simultaneously, fresh air is drawn in from the outside, passes through a heat exchanger, where it recovers energy and is then supplied into habitable rooms. We recommend ductwork that is from the unit to the atmosphere or installed within the unheated space should be insulated to prevent condensation forming.
For an MVHR system, we have to look at a high boost rate and also a continuous rate, just as we do for the MEV and DMEV systems. The minimum high extract rate is again defined in litres per second for each of the wet rooms, kitchens 13, utility 8, bathroom 8, and sanitary 6.
Here we repeat the slide from the mechanical extract ventilation, where the continuous supply and extract rate has to be calculated in 2 ways, and the larger of the 2 volumes will be used.
The total supply airflow rates should equal the total extract airflow rates. This will allow the system to be balanced, meaning the amount of stale air extracted from wet rooms is replaced with fresh tempered air into the habitable rooms. This applies to both the continuous rate and the boost high rate. This needs to be achieved by proportionally distributing the airflow into each habitable room. Please note, background ventilators should not be installed with mechanical ventilation with heat recovery, as they can provide unwanted additional ventilation and reduce the system efficiency. MVHR systems should be designed to avoid the moist air from the wet rooms recirculating to the habitable rooms.
Within Part F, it states that it shows examples of ventilation systems that comply. Alternative ventilation systems, such as PIV, positive input ventilation, may be used provided it can be shown to have an equal level of performance. This may be demonstrated through expert advice guidance, which could include the use of BBA certification or following BSI PAS 2035, which considers it to be an adequate means of demonstrating compliance. See page 22 of the ADF document, paragraph 3.6.
We now start looking at design considerations.
Noise is an important consideration that needs to be addressed, as noise pollution can be a concern within dwellings. Within Part F, it states certain noise levels should not be exceeded under normal operating conditions, not boost rates. Noise should not exceed 30 decibels within bedrooms and living spaces, and cannot exceed 45 decibels within kitchens and bathrooms.
To counter noise from units, there are various ancillaries that can be installed, such as attenuators, which can be utilised to reduce the induct noise in certain rooms or for entire systems. Acoustic enclosures, which can reduce the breakout noise experienced from the casing of the units, or acoustic top boxes, which can be utilised to reduce the overall induct noise on MVHR units. They also provide a neat ducting enclosure at the point of installation. Usually, a combination of these will be utilised to maximise any sound reduction.
As with sound, the location of the property can affect the level of pollutants that may be drawn into the building, either through trickle vents or through supply ventilation. Section 2 of Approved Document F states that ventilation systems should be designed to minimise the intake of external air pollutants. In an area of high pollutants, it is likely that this will only be achieved via the use of MVHR systems with high-grade filtration. Further information can be found via SIBC TM64 and TM40. Further expert advice should be sought during periods of high pollution concentration.
NOx filtration may need to be considered on city centre developments or where lower level dwellings are next to busy carriageways. Again, only applicable to systems that provide supply air rather than background ventilation. It should be noted that adding such filters will add to the pressure loss in the system and that these filters will need access for routine maintenance.
Within Approved Document F, there are 2 requirements to meet for installation and commissioning.
Mechanical ventilation must be commissioned by a competent person and notice given to the building control body. This applies equally to full systems and individual intermittent fans.
An installation comprises of many components, many of which are specified within Part F. Part F states that the system must be accessible to maintain the equipment and ensure that there are no obvious defects and all packaging has been removed. To the left is an example of a good installation where the unit is easily accessible, compared to a poor installation on the right where the unit is not easily accessible at all.
Rigid ductwork should be used wherever possible. The system should be designed to minimise the pressure loss, ensuring efficiency and sealed to prevent any leakage. Duct connections should be both mechanically fixed and sealed. Examples of a good installation with each connection sealed properly compared to a poor installation where the flexible duct has been taped together with parcel tape.
Flexible ductwork should be kept to a minimum. When it is used, it should be kept taut with no sagging and not have any tight bends, otherwise the system will not operate efficiently. As you can see from the image on the left, ductwork should be straight and have long sweeping bends where possible, not tangled with multiple bends as per the image on the right.
Airflow rates of all installation systems should be tested and recorded within the commissioning checklist. Some intermittent fans may not be able to have their speed altered. However, the ventilation rates must still be recorded on the commissioning document to prove compliance. Correct equipment should be used to measure the airflow rates, which is an airflow device and hood that has been calibrated within the last 12 months at a calibration centre accredited by UCAS to an accuracy of plus or minus 5%, not a homemade device.
In some scenarios, the configuration may prevent airflow from being measured. In this scenario, you will need to determine the flow rates as per the manufacturer's guidance.
As per Part F, there is a compliance checklist that needs to be completed, which has previously been part of the Domestic Ventilation and Commissioning Compliance Guide. This can be found within Appendix C, Part 1, and is shown on the slide. Part 1 contains the particulars of the system, address, and installer's details. Part 2A is an installation checklist. Part 2B is a visual inspection or pre-commissioning checklist. And Part 3 is for recording airflow measurements requirement from the fans. All sections will need to be completed in order to demonstrate compliance regardless of system type.
This takes us to the end of the presentation. We'd like to thank you for your attention and we welcome any questions that you might have.